Hey everyone, welcome to Swift Heroes. I'm super excited to join you again after I was lucky enough to talk in Italy last year physically before COVID started. Just want to start off before everything to tell you that usually I have a very fancy video camera and mic setup, and today I'm in this small room and these AirPods, and that's because my country is on lockdown again because of COVID. And I know it's a very difficult time for everyone, and I'm super excited to have a chance to talk to you a bit about iOS and try to brighten your day up a bit, like many of the other speakers that would uh, be part of this day. Okay, with that, let's get started. Today, we're going to talk a bit about Combine, Apple's reactive declarative framework for asynchronous programming. A bit about me before that. My name is Shai. I'm an iOS technical lead for Gett, the on-demand mobility company. I do a ton of open source work, especially managing the Arc Swift project, as well as the Arc Swift community and combined community projects. I talk in a lot of conferences, such as this one, usually more in person, but also remote conferences are pretty fun. Some of them are Try Swift, SwiftConf, Mobile Unplugged, and I also am a huge fan of hackathons, and I even won a few locally and internationally. I'm part of the RayWenderlich.com iOS team, where I work on tutorials and also a bunch of books. These are some of the books I worked on, and the latest of the bunch is this combined book, which I hope you all read, and if not, I suggest you do. So let's start from the top. What is combine? I always like starting from the dictionary definition when I teach something as complex as this kind of topic. So the combined framework is a declarative framework for processing values over time, and these values can represent many kinds of asynchronous events. This is a bit mind-blowing kind of definition, so let's focus on the most important portion, asynchronous. When you hear asynchronous, what do you think about? What is asynchronous? Basically, everything. Everything in your app occurs over time, asynchronously. That means networking, that means notifications, that means even UI events when you tap on a button, that's an event that occurs over time. So in combine, all of these things are unified under a single interface called publisher. You have consumers that can subscribe to these various publishers and be notified on the results of work or whenever things change in that specific publisher. So we have a publisher on one side that says, hey, I perform work and emit values as they change or occur. And on the other side, we have a subscriber saying, cool, I'd like to receive these updated values whenever they happen. And they just basically talk to each other. Our interest is basically trying to make as many things in our app a publisher as possible. I don't mean that you need to go ahead and make everything combined, but the more of these pieces you have, the easier your life is going to be because they compose really well together, as I'm going to show you a bit later in this talk. So really, as I mentioned, if all of our synchronous work is represented under the same contract, we get really cool compositional abilities. Today we have a bunch of ways to represent async work. For example, we have a tap on a button, which is this IB action. We have a .text property for text fields, and for network requests, we might use our URL session with a closure for the completion handler. In Combine, all of these things are presented the same way, publisher, publisher, publisher across the board. That means we can compose them. We have a unified way of representing how these different pieces of work occur in our system. So we can really easily reason about them, move them around, put them together, which is really cool and useful. Reactive and declarative, the two big buzzwords. So when you subscribe to a piece of information, you always get the latest values pushed from that source, from that publisher. And that lets you basically keep your app up to date constantly. Here's a good example of some regular Swift code. It doesn't use combine. We have a user that has $5 and they want to purchase a product that costs $10. We have this Boolean that says, can make purchase. Is the user's balance greater or equal to the product price? That's obviously false. Later on, that user gets $20 more. I would expect can make purchase to be true at this point, but it's still false. The reason is that can make purchase doesn't reflect the latest state of everything that occurs in your system. It's just merely a snapshot in time of whenever you calculated that Boolean. In contrast, if you see this combined code, you don't necessarily have to understand it, but it is basically kind of like reading an English sentence. You take the product price and you combine it with the latest value from the user balance. And then whenever the value of either of them changes, you automatically map it to is this greater than that? And you get a new publisher of Boolean types. So can make purchase now always reflects the latest state. Whenever anything changes, you will always have a guaranteed state of can make purchase, which is valid for your app. Let's talk about some combined theory. You gotta know the basics to write some code for sure. So we started from the top, publisher. So it is a type that can emit a sequence of values over time, like we mentioned before. It is a protocol that has two associated types, the output and the failure, where the output is the kind of values it can emit, and the failure is the kind of error it can fail with. So we also have strict types and strict failures here, which is quite useful. Publishers can emit three types of events. It can emit values, and it can emit two different completion events. Finished, which means everything completed successfully, and failure, which means it completed but something went wrong, and you get the associated failure type along with it. Publishers may emit as many values as they want, as long as they're not finished with one of the completion events I just showed you. So you have a publisher with the output type of int and a myError failure type. It can emit as many integers as it wants until, for example, we get an error event of that concrete type, or until we get a regular completion event, a finishing event. Any completion event terminates this publisher, and it guarantees that you would never get any more values as long as there was some completion event. The second part of the puzzle is a subscriber. So if we talk about publisher, which is a push-based interface, it delivers its values to one or more of these subscribers, the consumers, basically based on their demand. It has two similar associated types. This time it's the input, because it connects to the output of the publisher, and again, the failure type. As you see, those two must correlate. The output of the publisher and the input must match. Same for the failure, or you can't connect them together. You can subscribe to a publisher unless the types match. So really the only thing we are missing is some piece to connect the subscriber to the publisher so they can talk to each other easily, because they don't really have a good interface to talk together. That thing is called a subscription. So a subscription represents this connection between a publisher and a single subscriber. And that's where really most of the heavy work happens inside the code itself. The publisher provides this new subscription to the subscriber whenever it subscribes to it. There's a method called receive subscription, and it just passes it along. And then the subscription can push events to these different subscribers via two methods. The first is just receive, and you pass the input type, and second is receive completion, where you can pass one of the two finishing events and it pushes it directly to the subscriber. Once you're done with a specific subscription, you can just cancel it using a cancel method, or you can just deallocate it. Once you deallocate the subscription, it would also cancel any work behind it. This is really useful. It means that when you subscribe to a publisher, you also encapsulate that specific piece of work, and you can easily cancel it. That means if you do a network request, you can just cancel it, or you can deallocate whatever was invoking that request. That would also result in cancellation. As I mentioned, it would release any memory and resources allocated by any attached subscribers in that case. The subscription portion isn't only there to communicate between, to basically communicate between the publisher and subscriber. It also has another really big role in Combine. That's called back pressure. Back pressure is a fancy name for strategies on how you deal with publishers that emit way too many values too fast. For example, what do I mean by too fast? If I have a publisher that emits 10,000 values over a single second, we have this poor little subscriber saying, whoa, I don't know what to do with so much information. I don't know how to handle so much information so quickly. So what Combine did, which is really interesting and different than ArcSwift, for example, is that the control is transitioned to the subscriber. The publisher doesn't really do anything by itself. The subscriber has to explicitly say, I would like to receive up to X values, some demand that's called, and then the publisher will tell you, here are the values you asked for, and I will never give you more than you demand. If you told me give me 2 values, and even if I have 10 values, I only give you 2 values. The subscriber also has a chance to adjust that demand constantly based on the new values it gets, which is super interesting. And we have 3 types of demands. The first one is the most common one, and that's unlimited. Basically, give me everything you got. The second is none, and that tells the publisher to stop publishing events. And the last one is max with some X value to it, which means give me up to X values. Every publisher must respect this contract. Even if you, for some reason, make a custom publisher, you always have to respect and own the subscriber's demand. Another interesting semi-theoretical piece is called a subject. A subject is a special kind of publisher that you can manually send values to. It's really useful for bridging imperative code that you have in your system. So if we talked all this time about publisher, it is an immutable piece, it's read-only, and the publisher itself produces its values. You can't mutate it, you can't change it by hand. As opposed to it, with a subject, it is a read-write entity. You can subscribe to it, but you can also manually send values to it, push values to it. And then they would immediately be sent to all of the subscribers that specific subject has. Combine provides 2 kinds of subject. The first one is called a pass-through subject, and the second one is called a current value subject. And the names pretty much represent them. A pass-through subject only passes the events through, and it's really useful for representing events that occur in the system. Event means you touch the button, something just happened. For example, the user tapped the button, we can make a pass-through subject of type void that never fails. And whenever a button tap occurs, we can manually .send on the subject, and that would notify anyone subscribed to that button that a tap has occurred. An interesting fact is that new subscribers get values only after the subscription. It means that if the tap happened and you just subscribed, you're only going to be notified on the future events, which makes sense because it is to represent events, and we're not interested in the past, we're interested in the future. As opposed to it, we have the current value subject, which is useful for representing state. For example, a very stateful thing is a loading state. IsLoading is a current value subject of type Boolean that can never fail, and it starts with false. It has to have an initial value because it's stateful. I can send the value to it directly like I used to before, or I can directly use the value setter on it. Doing either of these things will send this new value to all of the subscribers. In this case, though, if I subscribe to it, I would always get a replay of the current value of that subject. So if I subscribe to isLoading right now, I'm going to know what's the current loading state, which is again why it's very useful for representing stateful things. To summarize this very heavy theoretical section, we have a subscriber and a publisher, and they are connected amongst themselves. Once they are connected, the subscriber is provided to the publisher. The publisher creates a new subscription to represent the connection between them and passes it off to the subscriber. At this point, basically, the subscriber and subscription talk amongst themselves, and the publisher is basically not involved as much. The subscriber says, hey, give me up to X values, the demand I mentioned earlier, and only when that happens, the subscription via the publisher pushes these values back to whoever subscribed and asks for that information, and the subscriber may adjust their demand as I mentioned earlier. Finally, whenever the work is done, the publisher pushes the finishing event through the subscription to the subscriber, and that's how we know the job is done and there's no more events to there are no more events to handle. Boom, you are very, very awesome. I know this is a lot to take in, especially if you've never done any reactive work, but you just need to think about it as reactive values. You have values, you have finishing event that could be either a good finishing event or a bad finishing event with an error attached to it. That's basically most of the things I just showed you, aside from back pressure. Now that we have all of this theoretical stuff in our bag, we can talk a bit about combining practice. Now you can actually use some of this. So now I have a bunch of these publishers laid out, but what can I actually do with them? So we get two built-in ways to consume these publishers, two subscribers basically. The first is called sync, and the second is called assign. Sync is a closure-based subscriber. That means we can just take a publisher like this one that publishes 4 strings, do publisher.sync, and then we get two closures, one to handle the completion event and one to handle the value event. If I run this code, I'm going to get, hey, there, Swift, heroes, and eventually I'm going to get completed with finished because no error occurred in this specific publisher. The second one we get is assign, which is super useful. It's like a binding mechanism, basically. It pushes every value from a publisher to a provided key path on a different object. For example, if we have the same publisher, we can tell it assign the text, assign every string that comes from the upstream to the text property of a text field. So that means if a publisher produces these 4 strings, it would every time change the text field's value based on whatever the publisher publishes. This seems a bit silly here where the 4 values are immediately published, but think about a very reactive system. It means something changed, that thing produces a new string, and that automatically updates your UI, your text field in this case. This is really the essence of reactive programming, right? So now we know how to get some values, and that's great, but it would be really cool if you could also modify the values emitted by the publishers, because sometimes the data we get isn't the one we actually need to consume and not the one we need for our app. To do that, we can use something called operators. Operators let you manipulate the upstream publishers and control the events emitted in really expressive and useful ways. So if we have a publisher and it goes through this operator, we get a new publisher basically that is modified by this operator that you put in between. If combined would be a language like the English language or the Italian language in this case, operators are really the words that make it. And the better your vocabulary is, the more words you know, the fancier the things you can do. And the more control you have over your code with combine. Operators are basically methods. It's simple chainable methods that have very same named variants in the Swift standard library. For example, I have this publisher that emits strings, it never errors out. And here I have a chain of the publisher with a bunch of operators attached to it. So you might already recognize some of these names. For example, we have compact map, we have map, filter, append. These are names we know from the Swift standard library, but here they are specific for publishers. I'm going to show you how they work right now. Let's start from the end. This append here only starts working once the publisher finishes, and we are just at the beginning, so let's grade that out for now. So the first value comes in. We try to turn it into a float, which we can, so it goes through the compact map. We then use an operator called remove duplicates. That one checks, is the previous value the same as the one I just got? And if it is, I can just skip it. This is really useful for information that comes in quickly. It means if the user types, we can ignore duplications of whatever they type in. Then we want to seal the number up. We get to 2. Then finally, if the number is smaller than 4, we just let it through. And then we got to this drop first operator. This one's an interesting one. It only happens once, and it drops the first value as it's named, basically. So this is the first value. It's going to get rid of it, and then it's never going to do its work again. We can ignore it at this point. Second value, we go to compact map. It's a float. It's a duplicate. It is not. We seal it up. It already is at 2, and it is smaller than 4. So it goes straight to our output. Then we get another 2. This one is again convertible to float. And then we get again to remove duplicates. This time though, 2 is actually the less value I got. So remove duplicates takes care of this logic for me without me having to write anything besides the words remove duplicates. Which is really awesome. That basically filters out the duplication. Then we get 2 string values. These both can't be converted to float, so they're just going to be dropped out. Finally, we have another number, 0.2. That's a float. It's not a duplicate. We can round it up to 1, and it's smaller than 4. At this point, our publisher finished, and that's going to trigger the append that we grayed out earlier. And append lets you add values or another publisher at the end of a completed publisher. So here, we are actually passing a stride between 0.3 to 0.6 with steps of 0.1, and that's just going to push these 3 values to the end of the publisher, and then the finishing event is actually going to arrive. Operators are themselves publishers, which sounds not too interesting, but why is it interesting? Because they are typed. That means that every operator that you use wraps the previous one in the chain, so your type gets very bloated very quickly. For example, here I have a compact map wrapping a publisher of string, never remove duplicates that wraps that compact map, a map that wraps that one, filter that wraps the previous one, and by the end of this stream, I get to this return type, which is bananas, basically. So imagine trying to return this thing from a method, let alone the fact that it is crazy to maintain such a long return type. You also are exposing exactly what your publisher is doing to whoever is consuming it, and that's something we would usually want to avoid. Yep. So luckily, Combine solved this very quickly for us with something called erase to any publisher. If you add erase to any publisher, you have the exact same publisher. It just uses type erasure and removes the typing, and then you get an any publisher of the final type after all of your operators. In this case, it's a float that never errors out. This is really, really useful, and it's really easy to return from your methods. Another really useful operator, especially for debugging, is called print. As the name suggests, it just prints out whatever passes through it. Here we have 2 strings, mobus and conf. The first print is before the uppercase, and the second print is after the uppercase. So here, for example, you'll see that we get a subscription for the first one, and then we have unlimited demand. This is the demand I showed you earlier. In this case, I've used a sync here, so the demand is immediately unlimited. And then we get the first value, mobos, and then we get the uppercase value. Then you get the second value, and then we get the uppercase value, and eventually you would get the 2, the finishing event. Now, this looks like a duplicated event. Just want to make sure it's understandable. It's just printing whatever goes through. It's all single events, but you're printing the before and after of the map operator in this case. So really, since, as I mentioned before, publishers unify how you represent asynchronous work, you can use all of these operators on whatever you want. So if you have a network request, it's quite easy to use map and retry on it, but why stop there? If you have a very long and heavy decoding session for a video, you can use the same map and retry. So that means that same vocabulary, the same language you learn is useful for every kind of asynchronous work you can wrap inside a publisher, which makes it a very transitional kind of skill. Let's talk a bit about Combine inside Foundation. So Apple provided us a bunch of really useful constructs for Combine around Foundation types in code. That means that we can use really useful things such as sequence.publisher, which I showed you a bit earlier. Basically, whenever you use .publisher on any sequence, that means array, range, stridable, you're going to get a publisher that emits these values sequentially. And that's quite useful for many use cases. You can even use it on a dictionary. In this case, it's conf app builders year 2020. In this case, it's just going to emit tuples because you can emit regular dictionary items, basically. They're not individual. Notification center.publisher is a really useful one. For example, it just lets you take a notification and wrap it inside a publisher. For example, if you have a UI responder.keyboard did show notification, every time I open the keyboard, I'm going to get a publisher that emits a notification about it, which is really useful when you think about the compositional capabilities. It means that whenever the keyboard open, I can create a new value from that changes my UI in some way or pushes the boundaries of my UI in some way, or I can make a bunch of publishers as a result of this notification that affect my entire system in a very reactive and declarative way. As a late transition, I always like to talk about baby Ethan, which is my kid. When Combine just came out, he was just born, so I always like to brag that he's as old as Combine is. But the year has passed, and he's a big boy now. He's like a year and 2 months. He's still as old as Combine. Combine a year ago was quite young and fresh, and today it knows much more. It is more capable, more stable. There have been many great bug fixes happening and many community projects that occurred since then. But since he was small, he always asked me, "Hey, Dad, can you tell me a joke?" Yeah, of course. He talked when he was a week old. I promise you. And I told you, "Sure, son, no problem." But he's very, very peculiar and wants very specific technologies. So he said, "You have to do it with Combine or I'm going to cry." So we're going to have to do just that. It's not a huge issue. Like we have a URL session data task, we also get a URL session data task publisher, which is very similar. Instead of returning a closure, it's going to return a publisher, which we can compose and use with other things. I made a URL request here to the icon has that joke API, passes the correct headers, and then I go to URL session shared data task publisher for a request. And that's going to return a publisher with the same data you would usually get in a closure, a tuple of data in your response, and a URL error failure. That means it can only fail with that specific kind of error. Then I can use sync, and on the receive completion, I can print if it was successful or failed. And in the receive value, I can print the data that came back from the API. In this case, it's a joke. Can a kangaroo jump higher than the Empire State Building? Of course it can. The Empire State Building can't jump. I know, so funny. We get a bunch more free things with this API. For example, the decode operator. This is an operator that only works in publishers of type data. It lets us basically save all the hassle of creating a new JSON decoder or any other decoder and decode the raw data type. We just do dot decode, pass in the type, pass in the decoder, and this entire very declarative chain would take care of the work for us. So in this case, in the receive value closure, I'm getting an actual concrete joke type. I'm not getting just data or a string. I'm getting an actual type that I can work with. We can also observe any KVO compliant key paths, which is very, very useful. That means I can observe the content offset of a scroll view. So as I scroll it, I can see exactly what's the current Y offset, for example. I can even observe the status of an AV player or even the queue priority of an operation queue. All these are really useful and you can create really interesting things with that reactive piece of data. Another tree that we got that is masked as a property wrapper is @published, which is very, very popular with SwiftUI. @published basically wraps a current value subject, the one I showed you a bit earlier. It's useful for representing state, like its underlying parallel. You can access it directly, imperatively, like you would any other variable. But if you use the dollar notation, you would get a publisher of its type. That means that I can subscribe to this thing. I can map on it. I can do all the regular things that I would do on a publisher. But I can still modify it directly like I would any other property, which is really useful and really helps with kind of bridging our imperative knowledge into this very declarative world. Let's do a quick detour talk very quickly about combining SwiftUI because they're so heavily tied together. So Combine's capabilities are deeply rooted within SwiftUI, and it's no mistake that they came out together in the same year. For example, these are just a few examples, but there are so many of them. Observable Object, which is a very popular protocol in SwiftUI, has a object will change publisher, right? If you look at the protocol. So this is a combined publisher, and it notifies SwiftUI whenever it needs to re-render things. Same for @observed object. It underlying uses observable object, which, as I showed you earlier, uses a publisher underneath the hood. We also have environment object, which does the exact same trick. Object type, observable object, that's a publisher. And finally, every view has an onReceive modifier, and you can use that one to pass any publisher you want and react in your view and in your view state to whatever that publisher just did, which is again very, very useful. This is just a very, very small peek. Basically, it just comes to show you how much these things are tied together and how much your knowledge um, in Combine is going to influence how you design your SwiftUI apps. Like every good project, you can't skip the community around it. So today, we do have some great reactive projects. For example, ArcSwift and Reactive Swift that preceded Combine. If you know any of these technologies, you basically know Combine. Yes, some of the names are different. Yes, you have back pressure, all these things, but the basic building blocks are exactly the same. Your reactive thinking that you developed over the years is the same. If you don't know anything yet, that's also fine. No one knows anything yet. It's relatively new technology. It's just a year old, as I mentioned. So you have all the time in the world to learn it and SwiftUI. It's all good. So what's the difference between Combine and some of the existing projects? First of all, Combine is iOS 13 plus, which is the biggest downside in my perspective. But now we have iOS 14, so that gap is getting smaller and smaller. It doesn't support Linux because it's not open source, I imagine. And while it is an advantage and disadvantage, Apple is maintaining Combine and Reactive Swift and ArcSwift are open source. It is nice to see the code open, but it's also nice that people are getting paid to maintain Combine. So we know long term we can count on it. We also get a bunch of UI binding stuff in the open source frameworks. We don't really get UI binding frameworks. There are community projects which I'll show you in a moment, but SwiftUI, not really binding. It's really an entire UI framework. The error model in Reactive Swift is actually the same as in Combine. You have a specific typed error. In Arc Swift, there are no typed errors. It just has an error, a regular Swift error. And finally, back pressure is only supported by Combine. Reactive Swift and Arc Swift don't support it at all. A bit about some of the open source work that's been done around Combine the past year. So I want to show you a bunch of cool projects. The first one is called Combine Cocoa. If you come from RX, you know RX Cocoa for sure. This one provides UI kit bindings and extensions for Combine. That means that if you have a UI button, you can get a publisher that emits whenever you tap that button. If you get a scroll view, you can have a publisher that emits whenever you scroll it. And even to the level of if you tap a cell in a table view or anything, basically. There's also Arcs Combine, which is a useful project if you come from Arcs Swift as well. It lets you turn Arcs observable to publisher and vice versa. We have combined data sources by Marine Todorov. That one is contains a bunch of really useful table and collection data sources and utilities for Combine. There's Combine X, which packs a bunch of really useful utilities that aren't inside Combine yet, unfortunately. I really recommend checking this project out. And finally, two really great projects. The first one is relatively new. The Point Free Code Swift Composable Architecture is basically built on Combine. Super, super interesting project. Very smart guys built it. I really recommend checking it out. And finally, we have Combined Feedback, which is based on Arc's feedback. It's a feedback loop style architecture that's based on Combine. We also have a community website, combine.community, that links to both our Slack that you are very welcome to join. We are happy to help whoever stumbles in there, and our GitHub organization. The big question is, should you use Combine for your specific scenario and your specific point in life of your app? So like anything, it depends. Is your app brand new and it's an iOS 13 and up? Sure, use Combine. This is actually a great opportunity if you start a new app. Use all the latest and greatest techs, especially if you are using SwiftUI, but even if not, Combine is quite useful. But for most of us, we have existing code bases. Should we use Combine with an existing code bases? So that kind of splits the two. Do you have some existing reactive code? Do you have existing RX Swift code more specifically? If yes, you can use something like Arc Combine to start your migration slowly. So if you're already on iOS 13 and up, you can write all your new code with Combine and still use your regular observables to connect stuff together because you're not going to convert everything to Combine at the same day. And if you're under iOS 13, you can still keep writing reactive code with Arc Swift and eventually migrate using RX Combine whenever your deployment target kind of raises up. If you don't have any existing reactive code, I would say use it as long as you support iOS 13 and up, because that's, you don't really have a choice. I wouldn't really try using any open alternative, because I would personally prefer using the official thing. If you want to learn some more and support my work, I would really appreciate if you check out the Combined Synchronous Programming with Swift book. Now, second edition actually coming out in very, very soon. You can get it at bit.ly/get combined book. And thank you very much. You can find me on Free4PC on Twitter, GitHub, Facebook, whenever you want. Just one last treat before I leave you for today. I'm going to raffle, I don't know how many, 3, 5, a bunch of free books, basically, a bunch of free copies of the combined book. Sign up on this link, bit.ly/free combined book. And when the conference is done, I'm going to send a nice video with a raffle, and you get a chance to win your own copy of the combined book. So I hope you enjoy it. Thank you very much, and see you very, very, very soon in the real world, I hope. Cheers.